Sure, I get that going. So can you see my screen?
Yep.
Okay. Thank you for the opportunity to talk to you guys. I really appreciate it. I retired, right in the midst of the pandemic. I've been working with the gap analysis project for a long time, since the 1990s. I took a little time off, and then USGS has a program where they hire retirees to come back in their experience services program. So it's a program that allows some of that institutional knowledge for to bring that back into the effort. And so I started that effort in January of this year. So I have to read this because I think New Solutions, who I really work for, wants me to. I'm assisting the USGS under a cooperative agreement with New Solutions. So I'm part of the USGS Experience Services Program. Mark Wiltermuth is the co-author on this presentation, and he's with the USGS Science Analytics and Synthesis Program. So today I'm going to kind of walk you through the gap analysis program, give you some history, where it came from, and give you what we're trying to do in the future as we try to harness some of the new technology that's available to us. So just to give you an idea of kind of the locations, we have a lot of universities that we work with. The main USGS office is out of the Lakewood, Colorado office. New Mexico State is down in Las Cruces in New Mexico. We are working with Boise State, Michigan State, as well as North Carolina State. So do contracts with them. So effectively what I did is I moved from the contract at New Mexico State into working more directly with USGS. So first of all, what is a gap and what are we calling a gap? What we term as gap is a gap in the lack of representation or underrepresentation of an element of biodiversity, whether that's a plant community or an animal species. And we're going to focus today on terrestrial vertebrate species. And the common mantra with the gap analysis program for the last 30 years is keep common species common. And so that's kind of the backdrop for this effort. The history of the gap analysis program dates back to the early 1990s. At that point, between 1990 and 2000 and a little later, all these gap projects were state-based projects. And so every state did it a little differently. And as we tried to put those together, we noticed that things were a little different across those state boundaries. So technology helped us start looking at regional perspectives. And from 2000 to 2010, we did 3 regional projects in the Northwest, the Southwest, and the Southeast. And that was based on imagery from 1999 to 2001. So we use Landsat imagery as a base layer to identify land cover. And those, as just to step back, the state-based projects were done imagery between 1990 and 2000 and something like that. So we did these regional projects and we wanted to move up and try to do a national effort. And we were able to complete that in 2016. And that was still based on imagery from 1999 to 2001. But we were able to do it for the entire conterminous US. And the products I'll show you in a minute, you'll be able to see those. There we go. So now what we're trying to do is we're looking at imagery from 2016 and 2023, and we're going to duplicate our efforts, but it'll be updated based on this new data set. So it'll be more current. Our current data products are a little dated. They're back to around 2000. So we need to do some update. And I did look in Maryland, Delaware, and New Jersey. There was a joint gap analysis project. It was completed in 2003. Ann Raspberry and some folks at Maryland Eastern Shore were the ones that completed that effort. So gap has been done at a state level in the Maryland area, but it wasn't part of a newer update. And so with the national effort, we covered Maryland, and with these two new updates, we'll cover that as well. So for GAP, there have typically been 5 different objectives of the effort. The first one is to map the distributions of natural vegetation communities. The second is to map predicted habitat of native animal species. And as I mentioned, it's terrestrial vertebrates that we're talking about here. The third is to map the natural protected areas that are managed for with intent for biodiversity. The fourth is to analyze these. This is a GIS effort. And so we analyze these on the computer and can come up with representations and statistics for this information. And the fifth objective has always been to take that data out to the public and get it used in wildlife conservation. So really the approach has been to create that land cover. Right now we're using Landfire. That's a national data set of land cover. We use that data to build these species models. We use ownership data and plan data to identify this protected areas for the US. And then we analyze that in a GIS framework. We can use those models to create species richness and analyze that as well. And then we can put that data out into other efforts. And one of the efforts that I've been working on is looking at ecosystem services. So we'll touch on that as we go through this process. So mapping the distributions of natural vegetation communities. Historically, we would do this as the GAP effort alone. But now we've started reaching out and we're using the Landfire program's land cover data set. And that's based on the Landsat platform, and the pixels there are about 30 meters by 30 meters. And so if you looked at, and I apologize, this is not the Orioles stadium, this is the Twins stadium, but a 30 meter by 30 meter pixel is that yellow square that you see. It's roughly the shape, the diamond or the base paths inside that field. And what we map to and what Landfire is working on is doing land cover maps at multiple scales. They use the National Vegetation Classification System, and it's a hierarchical approach. But we are looking at the macro group area or the group area, and those are still kind of broad land cover types, but they're specific enough that we can associate species with them, and we can map them from remote sensing. And here's a picture of the ecological system, which is kind of in between that group, macro group, but it's defined by being a group of plant community types that co-occur within the landscape with similar ecological processes, substrates, and environmental gradients. And so in this picture, you see 2 different ecological systems. You see the one in the foreground, that North American warm desert riparian woodland and shrubland with the cottonwoods right around that stream area. And then far away, you can see a cactus desert shrub type of ecological system. So Landfire, they focus on providing data to manage fires across the nation and Alaska as well. But they've created this data set, and the one that we are currently modeling is based on 2016 imagery, and it has 857 of what they call ecological vegetation types, or effectively those ecological systems I mentioned previously. So this becomes a foundational data set that we use in our modeling for the species. So the next objective we have is to map the predicted habitat for those species. And when we do that, we're modeling habitat for species that reside, breed, or use habitat in the conterminous US for a substantial portion of their history. And I like to bring up these three quotes that a lot of people use when they're talking about modeling, but I think they're always important that when we have a modeling discussion, is that models are tools for thinkers, not crutches for the thoughtless. All models are wrong and some are useful. That was by George Box. And then Yogi Berra also provided this one. In theory, there's no difference between theory and practice, and in practice there is. So these models are useful for us to look at what's going out on the ground, but they do not replace on the ground site visits. And those are always necessary when you're going to conduct management out on the ground. So we are currently trying to model about 618 species across the nation. The 2016 effort that we did, when we finished that was we did 1,590. As you can see over to the left of this, the regional aspects were a little easier. We had a lot fewer species, and as we kind of expand our reach, we had to include a lot more species, and it just took a lot more time. The other thing that we've been doing too at a national level is there are some species that we can actually model at the subspecies level, and so we are doing that. And I put fish down here because Michigan State has been modeling fish, and that's kind of a recent development. It's helpful. We're still trying to integrate from the terrestrial and the aquatic side how we're going to present that data and analyze that data, but it's good to have that base covered. So when we're talking about habitat modeling, there are two types of habitat modeling. There is deductive, and that's what we do historically, and that is knowledge-based or expert-based. You derive wildlife habitat relationships from the literature and from the experts. Then you identify that habitat, and it's really based on Greenvillian distributions. So we're really looking at all the habitat that species could be associated with. And the deductive approach is often kind of termed that general to specific. The newer methods that are available that are really strong and robust are inductive efforts. You may have heard people talk about max int or max entropy, random forest. There are a whole host of different algorithms that you can use. And these are based on species occurrence data. And it really is kind of the specific to the general. So the deductive is you get your knowledge and you throw it through the data layers and see where it predicts habitat. Whereas the inductive, you use those points, you drive those through the data layers and identify habitat and extrapolate where habitat is out on the landscape. So our modeling process has been to review the literature, compile a national range map for the species. We identify those habitat relationships based on that literature into a database. We run a GIS model, and then we have internal review of the model output. And then once that is done, then we will go out and have external review of the model output to give some to build us some confidence in the models and to make sure that we're modeling the species correctly. It's more of a graphical description of our process where we take that literature, we take online databases, we take the good old standard range books, and we create a range for the species. And we are using a polygon layer. It's the 12-digit hydrologic units. So we use that to create a mask of that range. And then we create that habitat model. So I mentioned earlier about the land cover being a base layer for us. We look at the primary vegetation, ancillary vegetation that might be associated with that species, forest edge, forest interior, patch size if it's appropriate, and any human impacts. We bring elevation layers in, elevation, slope, and aspect if those are appropriate. For some species they are, not for all species. And then we bring in hydrology as well. So one of the things, especially out here in the West, is riparian areas are difficult to map, but we can use the hydrology layers as a surrogate to identify those riparian areas here in the, especially in the desert parts of the Southwest. So we put that all together and identify where habitat occurs on the landscape. And then we use that range to make sure we are not predicting habitat outside of where the range of that species is known to occur. So the products we get out of that are down the lower left. You have that range for all these species. So over 1,600 species, you have a updated range. You have habitat, predicted habitat. That's the lower right-hand box. We provide all that data in online tools. We also have databases. And then for each species, we'll have a species habitat model report that discusses what actually goes into that model so that it can be replicated if somebody wants to. Another facet that we can use is we can take all those different layers. So we've got over 1,600 models. We can do species richness. We can do it on taxa. So if we want to look at birds, amphibians, mammals, or reptiles, or we can look at the total taxa. And so what you can see here is just kind of the richness across the nation. And this is based on the 2001 imagery, but you can see where the Southwest is highly species rich. You get into the amphibians, and the eastern part of the US is very species rich. And the bird species can be quite varied depending on the bird community that you're looking at. So now we have habitat models, and we want to try to see what areas are protected for biodiversity. And so originally this was a GAP specific product, but it's grown beyond that to become the protected areas database of the United States. And you may have heard of people use the term PATIS. And what that is it identifies the ownership of all the lands within the US. And then what we try to do is we try to go back in and look and use resource management plans and documentation to see what is the intent of the management on those lands. And we end up with this map, which is the GAP status codes. So the GAP status 1 is, and I skipped over that, that status 1 is that highest level of management for protecting natural land cover. So those are research natural areas. Status 2 lands have a very high intent, but there are some extractive uses. And so those are like wilderness areas that allow some grazing. Status 3 lands end up being multiple use lands. So most of the forest and BLM lands across the the nation fall into that status 3. And then status 4 is that there's no known long-term intent to maintain biodiversity. So those can be, they can be some of the private lands that, although they're currently managed for biodiversity, nothing is states that their long-term intent is for that, and that they might, tomorrow be sold and be used for a different purpose. So a lot of private lands are thrown into that status 4. So this is a depiction of that gap status across the US. And so that's another layer that we're going to use. And what we're going to basically do is drop that over each species map and be able to uh, identify statistics of how well a species is being managed. Within PADIS, this is the PADIS online viewer. You can go in there and you can either pick a parcel. This is just for the whole US, and you can see the breakdown of the status codes across the nation and who might be responsible for those lands. So as I said, we've got that land cover, now we've got habitat models, and now we have PADIS, and now we can analyze that data to identify the gaps that we're searching for. So the first thing is pretty simple. We can use PADIS. Typically what we'll do is we'll look at conserved lands, and those are status 1 and 2 lands. Those are those 2 status categories that have a high level of intent for maintaining biodiversity. So we can do the analysis for land cover and create those statistics and come up with graphics to help folks out. Or we can look at the species. And so this is just an example of what happens with the habitat model. That's the habitat model. We throw on that land cover or that PADIS data set, that gap status categories. And there we can identify the amount of land that for that species is in long-term protection for conservation. So that those red areas are where we have conservation lands and we have habitat. The blue areas are where we don't have that. So that provides us some ideas on where we can have opportunity to do conservation, whether that's working with private landowners, or it may be those status 3 category lands, Forest Service, BLM, something like that. But it gives us a perspective by species to look at conservation. And remember, one of the goals here is to keep common species common. Once a species gets listed as endangered, that's a federal issue. A lot of agencies have species at risk efforts. So they've highlighted species to triage, but most of the species aren't on any list. And so identifying those prior to problems occurring is extremely helpful, and it'll save some money. So we can do those similar statistics we did with land cover, and we can do those for each species. And then, like I said, the 5th effort really is to provide that information to the public and agencies so that they can use them in their efforts, either research, policy, planning, and or management. And there's a lot of benefits of this gap data. If you think about, if you're doing regional efforts, having that consistent data for CONUS, for the conterminous US, is helpful. For places like Forest Service lands, they have a lot of great data within their lands, but our data can be used to provide the ecological context, what's outside of their boundaries, and how might that affect their conservation inside their boundaries. We can do landscape scale assessments, and that landscape scale can be from county to state to region to ecoregion to the nation. Our data can also be used for sampling frames for finer study. It's been used in long-term decision making, And a lot of states, particularly with the first round of the state wildlife action plans, used gap data, and even in the second round. And so what we're hoping to do is, as we update this, we'll get that back involved in the updates of those state wildlife action plans. We've seen them used in regional conservation efforts. And then they're also useful in identifying ecosystem services. And that's one of the parts of the research that I've been kind of focusing on even now. Just to kind of clarify, so ecosystem services are those benefits or those services that we as humans derive from the ecosystem. And this is a chart from the Millennium Ecosystem Assessment, but it identifies these different services: provisioning services, supporting services, regulating, and cultural. But a foundation on that is life on Earth, or biodiversity. And so we've been looking at that, and articles such as this about how much we actually, what value we actually get from wildlife or the ecosystem. And this one was specific to wildlife. And they identified, if you see in that bottom chart, that economic sectors, they compared what the benefit we get from wildlife to computers and electronics, or sectors like utilities and even oil and gas. So we get a lot of benefits out of these, we get a lot of monetary value. And so how can we start using that to kind of model and understand? So we got together with the USGS and came up with an effort to use our models and develop some habitat metrics to see what ecosystem services that we could reliably get and put those together. And then look at kind of that multi-scale approach. Can we use them at a community, watershed level, a regional level, and national level? And that's all been fed into a national atlas that the EPA has created called the Enviro Atlas. So it has a whole host of ecosystem services within that effort. So the low-hanging fruit that we tackled first was just trying to come up with, we've got 1,600 models. How can we group these that agencies and private landowners would find as beneficial and would reflect either biodiversity or a specific ecosystem service? And so we grouped those into kind of that whole taxa richness. You can see the multiple taxa. We can break that up into winter or summer bird richness. The other one that we can actually start tying dollars to is we can look at harvestable species. Those species that state wildlife agencies are working with, that they are gaining money from either licenses. And there's been a whole host of efforts trying to identify just how much money big game people will spend to go out and hunt. And so there's that kind of grouping. We can look at rare species, and those are those species that have limited habitat out on the ground. In some cases, those species may end up being those that are next to be listed. And so identifying those, or identifying groups of species where we can do management on a parcel that encompasses quite a few species, will be helpful. We have the standard kind of T&E species. We looked at NatureServe. They have these G1, G2, and G3 species. Those are species that are ranked for vulnerability. The IUCN threatened terrestrial vertebrate species, so we can come up with metrics that reflect that. And then we can get more taxa-specific ones, such as Audubon's climate endangered species or threatened, partners in flight, birds of conservation concern, common birds of steep decline, and partners in amphibian and reptile conservation. So we were able to come up with all that, and we published that information out as a way to start to try to draw this ecosystem services effort, and provide us not values as in dollar, but values as in richness and importance. So this is just a compilation of all those different data sets. These are the maps that reflect those, whether they're taxa of concern, harvestable, rare species, or conservation concern. Other things that we can do with this data is start to look at where that data is protected. And so the blue line here, and I apologize, I didn't put it on the slide. The blue line is 30% of the habitat is protected. So it follows the Biden administration's push to protect 30% by 2030. The black line is an older biodiversity metric of 17%, but we can look within just the reptiles, if we want to look at snakes, lizards, turtles, or crocs, of how much habitat is protected or within those different conservation lands. So in this case, the red is the conservation land, is that status 1 and 2. And you can see in most of these charts, that doesn't meet that black or blue line. And these are all in quartiles. So a quarter of the species are in each one of these, except for the crocs. There's only 2 species in the conus. If we look at the multiple use lands, though, that purple, you can see we can meet a lot of those demands. And then again, that green is that private land, that unknown. That's the opportunity that we can start identifying landowners that we can work with to do conservation. Then we had the opportunity to do a little analysis just in the Mojave Desert. For the town of Apple Valley, they did a multiple species habitat conservation plan. And they were wanting to know if 2 key species in these areas are desert tortoise and desert kit fox. And so with our data, we were able to look at it. And if you look at the charts here, the two bars on the right-hand side, actually, the 2 tall bars, let me rephrase that. The 2 tall bars are the species richness, where the tortoise or the desert kit fox occurs. And the 2 shorter bars in each stack are where there isn't habitat for those species. So it lends credence to the whole keystone species perspective that in every case, whether you're comparing mammals, birds, total mammal, or reptiles, there is more richness on habitat with desert tortoise or desert kit fox. So the ecosystem services perspective can be used in a lot of different efforts, and our gap data can be used in a lot of the same types of efforts, addressing different questions depending on who is, what the questions are. We've got a lot of publications out, both USGS publications, fact sheets, and journal articles, and you can search for those if you're interested. And just kind of wrapping this up, where the future is headed for us is we are really looking at that inductive modeling to see how we can use that and bring in different lines of evidence to better the models that we have. So that's a future goal. We're trying to really incorporate that. We're expanding our geography to cover the entire nation, which means Alaska, Hawaii, Puerto Rico, the Virgin Islands, Guam, and the Northern Marianas Islands. So we want to fill out the entire national picture by including those geographies. And then we'll be looking at trying to incorporate climate and land and environmental change and how that affects species and habitats, and refining those biodiversity metrics to see how they can better be used by agencies. So I hope I didn't take up all the time. There's my contact information and Mark's as well. You can Google gap analysis, or this is the website for our project. Um, it's it's been a long time coming. We started state-based. Now we're at the nation, and now we can actually extend into Alaska and the island states and territories. So we're really looking forward to that. So I know there's comments in the chat, but I just open up for questions if people have them.
That was wonderful, Ken. If you can unshare, we can come back together and do Q&A. I know I saw a bunch of questions popping up. Are you able to access that chat box?
Yeah.
Pretty easily? Okay. Maybe I usually why don't you go through and do them, because I can't really see them.
All right. Let's see. Jerry asked, I didn't see climate as an input. How is this reflected? Use of location and elevation and ground cover as a proxy for climate. So much of the climate, we don't use climate now currently. Much of the climate data is at a resolution that's a little too coarse for our efforts, but we're looking to see how we might use that. And one of the kind of the easy ways that we could do that now is in the inductive world, we can create climate envelopes and then have the habitat within that. And so we're looking at that. But the elevation and the ground cover, yeah, the land cover are proxies for the climate. But one of the things we're interested to do is just try to start projecting out in the future so that we can, again, triage species. So that is one of the avenues that we're looking for. And then can you describe more the inductive machine learning models? Yeah, so those, we're really going to start hitting those. Our first effort was to create the nation, and then we want to do these two sets real quick based on 2016, 2023 imagery. But the inductive models, that machine learning is a really interesting perspective. And we're trying to figure out, our biggest issue with that is getting the species occurrence data across the entire range of the species. And that's been kind of an issue, but when we first looked at it in the mid 2000s, it was a huge issue. But now data is coming online, and there's a lot more species occurrence data. So we need to see how we can incorporate that. I'm personally a fan of the kind of an ensemble approach where you use multiple different algorithms. But that's one of the things we'll be looking at in the next 5 years, is how we can include that information in.
What is the sources of those information? Are those kind of like, are those bird breeding atlases, or those kind of things that happen locally?
Yeah, it can be breeding atlases. It can be iNaturalist, that people have the app on their phone.
Oh yeah, we all know that. Mm-hmm.
Yeah, so there's all sorts of it. Historically, it was the heritage programs and the wildlife, the state wildlife programs that had that data, or some of the agencies. And so it was a lot harder to kind of combine, but now all that stuff is getting kind of dumped in one bucket. GBIF, Global Bio, I can't remember the Global Biodiversity Information Facility. I can't recall what the acronym stands for, but it's one of those kind of clearinghouses. And so that's a place where you can get that. But all those things could be incredibly important. One of the ones that may have a lot of utility for us is the bat folks are doing their echolocations, and they're able to identify species based on the bats. And that could be extremely helpful because historically bat models have been tough because we've known very little about them. And so that may be a really rich data source, but we have to work through that and figure out how best to use it. See, at the topmost level, for whom is this information intended to be useful? Who needs it, wants it, uses it, etc. So really, the ones that use it the most. Oh, and is it freely available? It is freely available. The people that use it the most typically are states, and typically those states that have underfunded state wildlife agencies. So places like California has a well-funded wildlife agency. So they typically use their own stuff. Um, places like New Mexico has their wildlife agency isn't as well funded, and so they can use this. Nevada can use it. The other thing, and this is why it was so important with the wildlife action plans, at that time, nobody had all this data for all the species. You know, wildlife agencies typically focus on those that they are in charge of. So they're hunted species, or for some reason they've been listed, state listed. But having the entire breadth of the species is everybody was able to come in and kind of pick and choose their species. And so that was helpful. BLM uses it a lot because BLM land a lot here in the West is really checkerboarded. And so it's a lot of private land or reservation land in between. And so they don't have that full coverage like Forest Service generally has the full coverage. BLM doesn't, so they have that opportunity. They can use it. So those are a couple of the biggest users. We've had large counties use it. We've used the data doing some efforts to help Clark County, which Las Vegas, Nevada is in. And we've helped Pima County, where Tucson, Arizona is in. So county levels, governments have used it. Again, depends on the ability of that county. There are some counties in New Mexico that was just it wasn't on their radar. So
Hey, Ken, does EPA or Fish and Wildlife use that for any permit review processes, mainly for maybe Section 404 for wetlands?
you know, they haven't, to my knowledge. There's always been talk, especially with Fish and Wildlife, about using it in section 7 or 9. I can't remember right now. One of those consultations.
Not, yeah,
Section 9, isn't it? Or,
yeah, it's 9, I think.
okay.
Or
One
maybe
of
it's
the
7, it's Title 9, Section 7.
okay. I keep getting those confused, but some have used it for that. I mean, part of our issue was that, you know, we didn't get the national data sets out until 2016. So they were hesitant to use the state-based ones because all the models were so different. So with this new update, that's what we'll start working with them to see if they can use it. In the 404 stuff, that hasn't been used to my knowledge. One of the things, and it's a good and a bad thing, you know, we provide the data, and sometimes you look at reports and oh, they used our data and they never even contacted us. So we don't have a great way to track that. Arizona created a HABA map where they used a lot of our data. But they just took our data and then they modified it the way they wanted to. So you kind of have to look into their metadata to figure out if they actually used it.
Are there any gaps in users that you would want to see filled? Like who do you think should be using the data that's not?
We're focused on more the NGOs, the state, and the feds. The problem, I think, is we need to do more PR to make sure they understand that the data is there. Because I've had conversations and they thought, I had some people tell me they thought you had to pay for the data. It's like, it's USGS funded. It's all publicly available. It's all on a website. You can download it all. So it's been historically from the gap side, especially when you have universities, the university does their project and then they're off to the next project and they don't really get paid to do the outreach. And so we need to change that. And so that's one of the things we're working on. Private consulting firms have used it. In fact, I think they use it pretty heavily, but I only know they use it because I've gotten calls from several. And I don't go around searching EISs or environmental reports to see who's using what. And that's not always in Google Scholar or easily searched either. We do have a gentleman up at Boise State that's kind of looking at how it's being used within government and NGOs to see. He's going to give us some ideas of how we might get it better used. And I think, honestly, once we get these new updated data sets out, I think that'll be helpful. It's kind of hard to go out and expect people to use stuff that's based on imagery from 2000. And that's why our push right now is to do 2 different data sets and to get it current. Let's see here I answered that one. If a species is common across a large range, but with little or no GAP 1-2 protected areas, how do you tell? No, I can't. Whether that's because that species is resilient and does not need a special attention, or is at risk and should get more attention before things get worse. That is a good question. And it's one of those ones, it's a course level first cut. And if you really want to continue working on this, and especially if it's a specific species or group of species, you really got to dive back down into the data and learn more about it. Because if you think about it, we're mapping habitat, and there are all sorts of things occurring on that habitat that either from the protected areas database or through the habitat we're not identifying. With the new land cover, we should get, a lot of the western large fires, we should be able to identify those, and we'll see. But there are going to be some of those that we just didn't pick out just because it was a common species. Everybody thought it was there. And, if part of the thing is wildlife agencies are going to spend much time on those species because they think it's common too. So and they're struggling for funding as well. So, but that's an issue. And it's one of the ones that, trying to come up with different ways to address that. That's a really good question. Let me see. Yeah.
Were you trained as a herpetologist?
Yes. Yes, I lean that way. I got my master's at Texas Christian with Gary Ferguson, and then got a PhD at Mexico State working on leopard frogs. So those are my favorite taxa.
Thank you.
How did you guess that, Joe?
Ma'am, I'm a Lobo, and us Lobos know about New Mexico. And it is common knowledge that many people who are associated with the Southwest are herpetologists. And besides, the herpetologists are the most inquisitive people that ask these difficult questions about the environment. So obviously someone talking about would have to be a herpetologist.
and
Gotcha.
I have the herpetologist facial hair.
That is true. That is true. That is
And
true.
the examples that you used in your presentation were herp species.
Yeah,
So
That is
you gave
true.
you away.
yes,
Yeah,
yes,
it was concentrated toward herpetology when you mentioned species, and most people would pick the species that are either the least represented, which herps many times are, or the species that is their favorite or
right,
their working environment that they enjoy working with. So
yeah.
All
thank you.
right, Joe outed you, Ken. Um, I, hey, you mentioned earlier in the presentation that y'all used 857 different ecological units. Are those listed on the website anywhere, or
They aren't currently, they will be in about 6 months or so. But if you go to the land fire, if you do a search on land fire and look under existing vegetation type, they have those classes there.
okay,
Yeah. Yeah.
I'll do
We,
that.
in the around 2010, GAP was doing land cover and land fire was doing land cover. And I think people started going, why are we spending 2 buckets of money for the or very, very similar data sets? And so we let land fire do it, and we just take their data set now.
I'd just be very interested in kind of seeing what all of those different eco units are that they've come up with.
Yeah. Yeah. It's nice now because we've come to some kind of, it's fairly static, not as, I mean, veg layers are never going to be complete, or classifications aren't always going to be static, but when we started off in 2000, it was a moving target, and now it's much less that way. So, and they do Landfire does a refresh on their data sets every year. So they've got that process down pretty well.
All right, do we have any other questions? I can't see the chat box, but are there any other questions, Ken, or for Ken?
Let's see. I think I got all the questions. Yeah, got all those questions.
If we don't have any other questions, thank you so much, Ken,
You bet.
for
You bet.
sharing with us. And I know that we're all interested in kind of going onto the website and digging around there. I know I am more.
Yeah, feel free, and if you need to, contact me.
All right, will do. Take care.
All right. Thank you very much.
Thank you. Bye-bye, everybody.